Alright, since we struggled a little bit with making graphs from limit statements in class, I decided to do a few examples, so hopefully this will help you out a little bit more. So I actually color-coded each limit statement, so when we graph it, you can see each part. Hopefully that helps and doesn't make it more confusing. Just follow along and it should be okay. So our first statement here in dark blue says the limit as x goes to negative infinity equals infinity. What that means is as we move to negative infinity on the x-axis, our graph is going up towards infinity. So let's draw that. As we move far to the left, this graph is going all the way up towards infinity. So we did this statement. Perfect. Next, our red limit statement says the limit as x goes to -2 equals negative infinity. Remember, you can break this up into two statements, and you could say the limit as x goes to -2 from the left equals negative infinity, and the limit as x goes to -2 from the right equals negative infinity. So let's show that. Find -2 on your x-axis, right here, and we're going down to negative infinity from the left-hand side, and down to negative infinity from the right-hand side. Next, we have a function value, so we have f of 0 equals 3. This is just an ordered pair, so at x equals 0, our y value is 3. So you can draw a closed dot right there. Moving on, we have the limit as x goes to 0 equals 0. So again, we can break this up into two statements, and we have our limit from the left-hand side and our limit from the right-hand side, both equal to 0. So if we draw that, moving from our function we have already, as we go to 0 from the left, the function 0, and same thing, 0 from the right, the function 0. Now be careful, we don't cross that, we have a hole there, because we already have this function value of 3 at f equals 0. Alright, our light blue limit statement here says the limit as x goes to 2 from the left is negative infinity. So be careful, this is a one-sided limit. So as we go to 2 from the left, find 2 on your x-axis. From the left, we go all the way down to negative infinity. Now our orange statement says going to 2 from the right is positive infinity. So again, find 2, and from the right, it's going to positive infinity. Now our last statement, the limit as x goes to infinity equals 1, says as we move far to the right all the way to infinity on our x-axis, this function is going to flatten out at 1. And there we have a graph given the following limit statements. Alright, so now I have some limit statements for you. And a good idea right now is to pause the video and try and graph these statements by yourself. Alright, so now you can check your graph with mine and see if it matches up. If you struggled, just follow along and hopefully this will help out a little bit more. So to start, the first thing I always like to do is to plot my function values. So here I have f of -2 equals -2. So on my graph, I find -2, -2, and make a point. And f of 2 equals 1. So I find 2, 1, and I make another point. Alright, so those two are done. Next, I like to start all the way on the left-hand side of my graph. So that would mean this right here, negative infinity. So as I go all the way to the left, I know my graph is flattening out at y equals 2. So as we move to the left, this graph is going to flatten out at y equals 2. My next leftmost point is right here. As x goes to negative 2, it says I'm going to the value of 2. So find negative 2 on your x-axis, and as we go there, from the left and from the right, I'm going to this value of 2. Make sure you put a hole here so you can pass the vertical line test, since you already have a point plotted. My next leftmost value is 0. I notice that from the left and from the right-hand side, I have two different values. So as I approach 0 from the left, I go all the way down to negative infinity. And as I approach 0 from the right, I go up to positive infinity. So those are all set. My next leftmost value is x going to 2. So if I go to 2, my limit is negative 1. So that means from the left-hand side, I go down to negative 1. And from the right-hand side, I go down to negative 1. Again, I have a hole here, so I can pass my vertical line test. Now my last limit statement, the limit as x goes to infinity, that's moving all the way to the right, and I'm flattening out at negative 2. So if you got a graph that looks something like that, then good job. I'll do one more example if you want to follow along with me. If you think you're all set, then good job. As for the quiz on Monday, do not worry. I just wanted you to watch this video. All right, one last example here. Go ahead and pause the video so you can try and graph it. I'm going to do it right now so you can check your answer with mine. So first thing I always do is I plot my function values. So I see I have f of 0 and f of 2. So let me plot those points. At f of 0, my value is 5. So 0, 5, I have a dot. And 2, negative 1, I have another dot. So I did those, so I'm all set. Next, I start with my leftmost value on the x-axis. And here that is as x goes to negative infinity. I see I'll have a horizontal asymptote, or I'll flatten out at y equals 4. So let's go up to 4. And as I go to negative infinity, I'm going to flatten out here. So that's all set. My next leftmost point is negative 3. So I see I have, as I approach negative 3 from the left and from the right. As I approach negative 3 from the left, I go up to infinity. So let's find negative 3 on our x-axis. And from the left-hand side, it goes up to infinity. Now, negative 3 from the right-hand side is going down to negative infinity. So I can draw that in. So those two are all set. My next leftmost point on my x-axis is as x goes to 0, I see my limit is negative infinity. So I remember that this means from the left-hand side and from the right-hand side, I go down to negative infinity. Now my last limit statement here is the limit as x goes to infinity equals 1. So that means as I go all the way to the right, this graph flattens out at y equals 1. Now, two things I need to remember are I need to pass the vertical line test. So here at f equals 2, I need to make a hole since we already have a function value at f equals 2. So with that hole, your graph is complete.